Students, this is the second portion in the review packet, and unit number 3 and unit 4. We're going to finger track and read out loud all the instructions. Let's take a look at problem number 2 here. It says set up a thing equation and then circle plug chug, solve for x, then find all possible angles in the diagram. Let's take a look at number 2 and see what we have here. We have here an exterior angle, and then we have two remote interior angles. And don't forget that an exterior angle is equal to the sum of the remote interior angles. So now we're going to circle plug chug. This exterior angle, 9x minus 7, is equal to the sum of the corresponding remote interior angles. That would be 25 and 4x plus 8. Now you collect like terms, and then you solve for x. You can do your own algebra, and once you're done finding x, whatever value you get for x, I want you to plug it in right here, and then you should notice, and here, and you should notice that these two angles here add up to this angle on the outside. Taking a look at number 6. It says state if the two triangles are congruent by side, 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 angle, side, or angle, angle, side. When you're looking for congruency, the first thing you want to look for is pre-marked. Things which are already pre-marked. Then you want to look for freebies. And there's 3 main freebies. You want to watch out for vertical angles, reflexive sides, and reflexive angles. So here in this particular diagram, number 6, we have a pair of angles, and then we have another pair of angles, and then we have a reflexive side down the middle. So the question is this angle, side, angle, or is it angle, angle, side? That's the main thing. And how do you know the difference? If it's angle, side, angle, the side must be squeezed between and touching both angles, which in this case, if it was angle, side, angle, the side would be here on the outside between the two distinct pairs of angles, but it's not. So this one is we have a pair of angles and another pair of angles, then a side. So this is angle, angle, side, or as I called in the earlier videos, the tail. Number 13 and 14. Basic idea here is that all triangles add up to 180. That's the first and foremost important thing you need to remember about triangles, that triangles add up to 180 degrees. 2 more things you want to hunt for here, of course, is linear pairs, which means angles that add up to 180. They share a spine, they make a line. So watch out for linear pairs. Also watch out for vertical angles, of course. So looking here, we're going to find everything possible. We're going to start with a linear pair. So we sweep the 110. And now physically sweep the 180. And 110 minus 180 gets you that squiggle right there, which of course is 70. And now we're going to go with the second property there, is that triangles add up to 180. So we're going to add 70 plus 40, which of course is 110. We're going to take that away from 180. And we get 70 as well. So down here, this is 70. And we go like that. That is also 180. So up here, 73 plus 70, excuse me, is 143. 180 minus 143 is 37. So that means this is 37. And now you can take it from there. You find the rest. Notice you have another pair of vertical angles, and you keep finding every possible angle using these three properties. Triangle adds up to 180, linear pairs, and vertical angles. Number 16, we have one more layer that you need to watch out for. So the original things in the other problem was to watch out for triangles add up to 180. Second thing was to watch out for linear pairs that add up to 180. Third thing was vertical angles, which are congruent. Now we're going to add one more, and that is when you have two equal sides, you have two equal angles. So when you do your hatch marks like that, you follow the hatch marks like arrows, and then you get your two equal angles. Two equal sides, two equal angles. So using these four properties, 1, 2, 3, 4, let's see what we can find here. So at number 16, we have two equal sides, which means we have two equal angles. So if this is 61, over here must also be 61. Now we add 61 and plus 61, and we get 122. We're going to go 180 minus 122. We get 58. So that means this is 58. And of course, you should notice that there's a 90 degrees here. So 58 away from 90 gets you that pink angle. Then notice the hatch marks here. So find the pink angle. And then the hatch marks will lead you to another two pair of congruent angles. It's your job to find the rest there. And you're ultimately going to be finding the answer for this angle too, right here. Says, each figure shows a triangle with one of its angle bisectors. Trace and label each angle in different colors if possible. Write a thing equation, then circle plug chug, then find the requested angle. So the first thing we need to establish is that this is an angle bisector. Which if it's an angle bisector, that means this angle here is being cut in half. So sweep and hatch. So now we're going to use two different colors. We're being asked to find TUV. So here's TUV. That's what we want. If we know that angle 1 is 23x minus 2. This is angle 1. And angle 2 is 22x. Now we're going to do a thing equation first. Because of the angle bisector, we know two things are true here. We know that angle 1, the measure of angle 1, equals the measure of angle 2. We also know that the measure of angle 1 plus angle 2 equals the measure of angle TVU. We're going to see what we can work with here first. We have angle 1, so we circle, circle, plug it in. Equals, circle, circle, plug it in. Now you're going to solve for x. Once you solve for x, you're going to plug it into that equation and get angle 1. And then once you have angle 1, get angle 2. And then remember that the measure of angle 1 plus the measure of angle 2 equals our target equation, which is measure of angle TVU. So first, you do the basic algebra and solve for x here. Next one, it says each figure shows a triangle with one or more of its medians. Trace and label the given segments in different colors if possible. Use a thing equation, then circle, plug, chug. Find the requested segment. So here we have a median, which means that's a midpoint, and that means point J is what's called a centroid. And here's what you need to remember is when you have a centroid, the vertex to centroid segment is twice as big as the centroid to the opposite midpoint. So what we have here is that we have a 2x and x relationship. One's twice the measure of the other. I prefer to write it like this. It takes going this way. This is half of that. Going this way, that is twice of that. So with our given information, we have here f to j is 2x minus 2. This is fj here. Let me make it nice and big so it's easy to spot. That's fj. And then we have jl, which is the blue. Now let's see what we, and we're being asked to find f to l, which is this whole thing. So let's write our thing equations first. We know first that it takes 2 JLs, 2 of the blue statements, 2 JLs to make 1 F to J. That's one important statement. And then another thing equation, F all the way to L equals FJ plus JL. The red equals the green and the blue together. So there's your thing equations. Now let's see what we can work with here. Let's circle FJ. FJ is right up here. FJ is 2x minus 4 equals 2 parentheses JL, which is 2x minus 11. Because I see 2 goes into the number on both other sides, I'm going to divide by 2. And I end up with x minus 2 equals 2x minus 11. From here you solve for x. Once you solve for x, you're going to find this distance f to j. You're going to find that distance j to l. And then you use that right here to find f to l. Check your answer in the back when you're done. It says, state if these three numbers can be measured the size of a triangle. Now, how do you remember that any two sides of a triangle have to add up greater than the third side? So any two sides of a triangle have to sum greater than the third side. You have to do all three potentials. So the easiest way to remember this is eyebrow, eyebrow, smiley. So we go like this. We ask ourselves, 17 plus 7, is that greater than 8? And it is. So check. Let's do the green. 7 plus 8. Is that greater than 17? And the answer here, since this is 15 on this side, the answer is no. That one doesn't work. So this one's a yes. This one's a no. Then here we're going to go 17 plus 8. Is that greater than 7? The answer is yes. So that's yes. But all three have to be yes for it to be a triangle. So this whole thing is no, it's not a triangle. It says, with the given information, order both the sides and the angles from least to greatest. So we have a triangle, UST. So let's just draw that triangle. Here's U, here's S, and T. Let's label it. U is 45 degrees. T is 65 degrees. And S is 70 degrees. This is really easy to order. 45 is the smallest angle, so sweep it. That means this is the shortest side. T is the medium angle, so that's our medium side. And of course, 70 is our largest angle, so this is our longest side. So least to greatest looks like this. The shortest side is going to be ST. The medium side is SU. And the longest side is going to be UT. Number 30 says state whether or not the polygraph is similar, explain why or why not. The test for similarity is SCARE. And SCARE means similar, means congruent angles, ratios, equal. Congruent angles, similarity means congruent angles, ratios equal. So first, let's check for congruent angles. Obviously here with right angles, the angles match. So let's now check our ratios. So we're going to go this way, 12 to 30. 6 goes into 12 2 times, and 6 goes into 30, of course, 5 times. Let's try 14 to 35. And 7 goes into 14 twice, and here 5 times. So we see that the ratios, the angles are congruent, and the ratios equal. So we would say, yes, these are similar in number 30. It says state if the triangles are similar by side, 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 angle, side, or angle, angle. If not, write not similar. So side, 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 to do side, side, side similarity, you have to test 3 side ratios. To do side angle side similarity, you're going to have to test 2 side ratios. And to get angle-angle similarity, you are going to have to see if there are two congruent angles, two pairs of congruent angles. So let's see which one might be going on to play there. I'm going to give you a moment to write that down. Okay, so in number 32, let's see first if we have congruent angles. And of course we have our bow ties, so we do have a pair of angles. So we're potentially in the running here for side angle side or angle angle. So let's first see if there's any other congruent angles. If we were told that these were parallel, we could get armpits of the Z. But notice we aren't told that those are parallel, so we can't use that. So let's test the ratio of the sides here. Let's first go this way. 30 to 130 and 24 to 104. So 30 to 130. Let's see, 5 goes in here 6 times, and 5 goes in there, let's see, 2 would make it 10, 3, 0, 26 times. And we can go down one more farther, so 2 goes into both of those. 2 goes in there 3 times, and then 2 goes in there 13 times. So this is a 3 to 13 ratio. Let's check here. What goes in here maybe 3 times? Well, 8 goes in there 3 times. Let's see if 8 times 13 gets us 104. So this is going to be 2, 24, so there's 4, carry the 2, and that's going to be 104. So 3 and 13 as well. So my ratios do match here. So I have side angle side similarity. So yes, they're similar. Now once you establish similarity, then you want to complete the similarity statement. So let's see the order here. J, K, L. J, K, L. Notice the order here. I went from center, short, up, and around. So my match is going to be center, short, up, and around. So my match is going to be triangle JVW. Okay, in 36, 37, 35 through 40, when you're dealing with proportional sides, these are the kinds of things you want to look for. Step 1, the name of the game is match and mirror. Match and mirror. That's the most important step, is to make sure you match sides up and mirror the proportions. Match and mirror. What kind of proportions should you be watching for? Proportions where you can pull triangles apart and then match them up that way. Proportions where you can see segments and parallel lines. Segments and parallel lines. And then the third proportion you should be watching out for is one with angle bisectors. For example, if this was an angle bisector, these segments here would be proportional. Let me make a proportion so it's easy to see. So when you have an angle bisector, this segment over its corresponding side is the same as the other segment on the other side over its corresponding side. So when you have an angle bisector, those segments created by the bisector are proportional. And of course you can cross multiply. So these are the four things. First, match and mirror. Look for similar triangles or look for similar segments. And when you have an angle bisector, those pieces are proportional. So taking a look at 36, I see here I'm going to match and mirror, and I'm going to use colors to help me match. I can match this way. Those match, they're in the same position. And those match, and they're in the same position. So I'm going to actually show you both ways. So I could go 2x plus 2 over 16 equals 25 over 20. Notice I'm in the habit of putting the arrows to help orient myself as to which direction I go. I could also look at it like this. I'll get the same thing. I can see these as a match this way, and then these as a match this way. Both work. I could go 25 over 2x plus 2, and then I have to follow the same direction. If I'm going point towards bottom, I have to go 20 over 16. If you look very carefully, you're going to end up with the exact same thing. Look, 16 times 25, 16 times 25 equals 20 times 2x plus 2, 20 2x plus 2. This is what's called matching and mirroring. You match at the sides, you mirror the direction. Very important that you color code this and that you physically draw your arrows and trace stuff out. That helps your brain recognize what matches and what mirrors. When you're done, whenever you solve for x, plug it in and make sure that when you plug x actually back in, the ratios all match up.